Hi, yeah, I'm Cameron. I used to be at Apple and Change Healthcare, and I'm sort of like a data sciencey person. And yeah, I'm going to talk about the best package for doing AI in the universe of Python. So I'm going to start off by talking about what AI actually is. So the problem with AI is kind of defined as like artificial systems that mimic human intelligence. And the problem with that is that human intelligence is like broad and varied. So like anything from like having a line fit to some points to like the Terminator is like all under the giant sort of field of artificial intelligence. And that leads to some problems and interestingly makes things kind of like the field very broad. And there's a million packages we have to deal with this chaos. But and yeah, and AI can do cool things like accurately identify animals, and like Siri is AI as well. But broadly speaking, AI systems are software systems, and sort of the algorithms that are used behind the scenes sort of fall into two very broad categories, which are like rules made by people or rules that are learned from data. So we've all heard about deep learning and all these cool things that are happening. Even simpler like machine learning algorithms like logistic regression are all things based on being learned from data. However, there's like a much older way and in some ways cooler way of doing things, which is like expert systems, rules that are made by people. And the sort of sneak preview of this is that rules are important that are made by humans. So there's lots of packages out there. Here are a few of them. I have some cool logos here. These may or may not all be real. Things for like visualizing data, building models, sort of playing with data. These are all the sort of things that data scientists use every day. We have big data systems here, but there's kind of one that I'm not revealing yet, I'm teasing you with, that is sort of more important than all of these. So before I reveal this package, it's really easy to like over-engineer solutions to things. So there's this like really amazing and also like infamous blog post from a few years ago by Joel Gruss about, he was given this sort of like, it's kind of like if you're a software engineer or something and you're in an interview and you're given like FizzBuzz as a challenge and you have more than 0 years of experience. It's kind of like an insulting thing to be asked in an interview. So when he was given this challenge, his response was to use TensorFlow to sort of train a model to do FizzBuzz. It did like a good job, like an okay job, but he was not offered the job in the end, surprisingly. So yeah, so this is an example of how you can sort of like over-engineer, take a simple problem, make it harder than you have to. Okay, and now the drum roll. The real package that's really cool is, it's actually in the Python standard library. No need to like boot up Conda and download anything. It's RE. There's also a regex package, which is better. But people kind of, when I talk to them about how cool regexes are, they're usually afraid because regexes are like hard to learn. They have like a scary syntax, and most people only use them when they're like grepping for things. So they've only seen them in their terminal, and it's not even like real programming because it's like not in the right spot on the Chomsky hierarchy. So that's people don't like them. But regexes are cool. Sort of like some of the earliest intelligent agents. Like up here is ELIZA, which is really old, and it's basically a system of regexes to like match and replace text. And ELIZA's goal was to imitate a Rogerian psychotherapist. And like if you're a Rogerian psychotherapist, your goal is to sort of like help people overcome their horrible problems by like repeating their problems back to them, which I don't know if that's actually a good idea to like help people out, but it's actually not too hard to imitate with a bunch of regexes. So ELIZA did a pretty good job, and then Siri, which I worked on for a while, is unfortunately the delta between ELIZA and Siri is not huge for like 50 years. So yeah, so like Siri includes lots of like cool deep learning under the hood, a bunch of great models, but the problem is that if you've ever played around with like language data before, is the sort of data you get when dealing with words, the distribution is exponential. It follows like a Zipfian distribution, which means that lots of the items you're looking at are very uncommon. So like if you have a corpus of the English language, like the word the will account for like 10% of all the words. And then the word like pterodactyl will be extraordinarily rare. So if you're trying to like pronounce pterodactyl, you're gonna be in trouble. And there's this difference in like English between the way words are written and the way they're pronounced, which if you've ever seen like GOTI, like G-H-O-T-I as the pronunciation for fish, you'll know that this is a problem. So Siri, which is great, has under the hood tens of thousands of regexes that have been hand designed by people to do things like, well, we have this word here, like ST, what is that? It's actually street. Okay, we can regex it. It's not $sign, it's Kesha. OOO is an abbreviation, and that's an emoji. So these are sort of like glue that happens everywhere, and regexes are all over the place in like your coolest virtual assistants. They're there. So, you know, there's people doing the deep learning, but that's never gonna solve the whole problem. Also, and I'm not gonna dig into this too much, but you can build like this is from the UC Irvine spam bank data set, and you can build like an actually okay model by using a couple of regexes to see what's a spam message. So there are spam texts, and as you might guess, like the word free and the word like Viagra occur primarily in spam, not in real text from your friends. But the real reason why you should consider regex models if you're a data scientist doing modeling is because if you have like a non-technical boss, or you're trying to explain like your V0 algorithm to other humans who aren't data scientists, you're out of luck if you're trying to explain how your deep learning model works. However, if you've built a regex model that has a few simple rules to match text and make predictions, you're going to have a much better time because even non-technical people can sort of understand how regexes work. You're matching text and you're making choices. So I would advocate, if you're a data scientist and you're working with text and you're building models, to regex your problem until forced to do otherwise.